Today we are going to start talking about inequalities. Specifically, we're going to talk about how to graph and write inequalities. So first we need to define what an inequality is. An inequality is a mathematical sentence that says two things are not equal. And the symbol we use tells us how they are not equal, and there are four different symbols. If you look just below there on the left side, that very first one, when the pointy side is to the left and the open side to the right, that is a less than symbol. Below that would be the opposite then. It is a greater than symbol. The next two both have a line underneath of it, which means or equal to. So the next one would be less than or equal to. And the last one would be greater than or equal to. So on the right side, we're going to practice using them just a little bit. When you use inequality symbols, I know a lot of people get confused about which one they should be using. I know one of the tricks you probably have learned before, and it still works, is think of it like an alligator's mouth. The open side should be pointing towards whatever the larger number is. So in the first practice problem there, we have -8 being compared to -5. Remember, when we're in the negatives, the further away we are from 0, the smaller the number actually is. So that would mean that -8 is less than -5, and that means the open or bigger side points towards -5. Below that, those straight lines tell us absolute value. Absolute value is the distance from 0. So the absolute value of -2 is just 2, and the absolute value of +1 is just 1. And the absolute value of -2 is greater than the absolute value of +1. And the final example there, -0.75 is less than 0. A solution is any value for the variable that makes the inequality true. So there are multiple solutions, and we can graph these on a number line. In order to graph them, we first have to place a dot on the solution. And there are two different types of dots that we're going to use. We could use a closed or filled in dot for the symbols less than or equal to and greater than or equal to. It's that or equal to part, that line at the bottom, that tells us we have to close in the dot. We color or close in that dot because all of those possible answers include the number the dot is on. So we're going to color it in like a bullseye. The other option would be an open dot, and we use that for less than and greater than. And we leave that dot empty because possible answers do not include the number that the dot is on. And the final thing we're going to do is draw an arrow in the direction of all of our possible answers. So one thing to keep in mind is the easiest way to graph is when the variable is on the left side, and usually it will be. However, we can always rewrite it so that the variable is on the left side if it isn't already to start. So we've got some examples below. The first one is x is less than -9. Since my variable is on the left side, I can go ahead and start graphing it. And what I always want to start with is just a blank straight number line with arrows on each end. Those arrows show that it keeps going in both the negative and positive direction. A common misconception or a common mistake that people make is that you need to have 0 on the number line, and you actually don't. There are a lot of situations, like in number 6, where having 0 on the number line would not make sense and it would take a very long time to do. What we do need to include on the number line is the solution, and the solution in number 1 is -9. So right in the center of my number line, I'm going to put -9. We also need at least one number larger to the right, and that would be -8. And we need at least one number smaller to the left, which would be -10. From there, we're going to put a dot on our solution. So a dot is going to go on -9, and because it's just less than, it's going to be an open dot. I will not color it in. And my inequality tells me I want numbers less than -9. So my arrow should go towards those numbers that are smaller than -9, which means it's going to go to the left towards -10. Another way to figure out which way your arrow is going to go, and this only works when your variable's on the left side, is your inequality symbol looks a lot like an arrow to begin with. It looks like it's pointing to the left, and so does my arrow and my number line. So we can use that to help us. So let's practice again in number 2. We have y is greater than or equal to 11. My variable's on the correct side, so I can just start with my blank number line. My solution goes in the center. One number larger to the right, which is 12. One number smaller to the left, which is 10. Because it is greater than or equal to, that line at the bottom, or that or equal to part, tells me I'm going to color in my dot this time. It's going to be colored in like a bullseye. Then for the direction of my arrow, again, you can think about this 2 different ways. The inequality tells me greater than, so I want numbers bigger going to the right. Or I could look at the inequality itself and it already looks like an arrow pointing to the right. So my arrow on my graph should go the same direction. With number 3, I have m is less than or equal to 0. Since my variable is on the correct side, I'm going to start with my number line. This time, 0 is the solution, so 0 will be in the center. One number larger is a positive 1. One number smaller is a negative 1. Since it's a less than or equal to, I'm going to color in my dot on 0. And if I look at my inequality symbol, it's pointing towards the left, towards the smaller numbers. So will my arrow. Number 4 is the first one where the variable's on the right side. So we want to rewrite it so it's on the left side. So I'm going to write W first. Now we've got to make sure that we write our inequality symbol correctly here. There are 2 ways to think about this. First way, if you look at the original problem, that open side, that larger side is towards my variable, or it's next to the variable. So when I rewrite it, it should stay that way. The open side is going to stay next to the W. The pointed side will stay by the 25. Another way to think about how to rewrite it is if I'm flipping the side the variable's on, I should flip my inequality as well. Now this is what I'm going to use to graph. So I'm going to draw in my graph 25 in the center, 26 to the right, 24 to the left. Since it's just greater than, it's an open dot on 25. And now that I've rewritten my inequality, I can look at that inequality symbol and see it's pointing to the right. So should my arrow. With number 5, my variable's on the correct side this time. I'm going to draw in my number line, my solution in the center of 134, one number bigger to the right of 135, one number smaller to the left of 133. Since it's just greater than, it will be an open dot. I do not color it in. And if I look at my inequality symbol, I want greater numbers, so I'm also going to the right, just like the inequality symbol points. Number 6 is another one where I have to rewrite it, so the variable's on the left side, so I'm going to write H first. If I am flipping the side the variable's on, I should flip my inequality symbol as well. Or I could have thought about how the pointier side was towards my variable, and it stays that way. Now this is what I'm working on graphing. Draw in your number line, your solution of negative 546 in the center, one number larger, negative 545 to the right, one number smaller, negative 547 to the left. Since it's less than or equal to, I color it in, or equal to tells me to color it in. And since my inequality is pointing to the left now that I rewrote it, so should my arrow. If you have any questions about graphing inequalities, please pause here, check in with your teacher, ask any questions. If not, go ahead and flip to the back. And we're going to talk about writing inequalities. A little while ago, we talked about different words that tell us to use addition, subtraction, multiplication, and division signs, as well as equal signs. Now we're going to talk about words that tell us to use less than, greater than, less than or equal to, and greater than or equal to. So we're going to talk about something they all have in common at the end, but right now I'm just going to go through and fill in this table. You follow along. In the less than column, we have six or so different phrases to write, so leave yourself space. The first one is very simple. It is less than. The next one is fewer than. Third is under. Fourth one is below. Fifth is lower than. And the final one I'm going to go over with you today is smaller or shorter than. All right, so moving on to greater than. Again, we have roughly the same amount, so make sure you leave your space to write. We have is greater than. Is more than. Is larger than. Is above. Is over. Is higher than. And the last one for this column is going to be is bigger or taller than. All right, in the less than or equal to column, we have, again, roughly the same amount, about 5 of them. So we have, the first one would be, just like it sounds, is less than or equal to. Next, is at most. Next, is at minimum. Or, I'm sorry, is at maximum. Is no more than. And the last one for this column, does not exceed. In the greater than or equal to column, again, about 5 of them. First one is the obvious one, is greater than or equal to. The next one is at least. Is at minimum. Is no less than. And the last one in this column is not fewer than. If you're looking at all of these columns, what you should notice at this point is nearly every single one of these phrases starts with the word is. If you go back to when we were talking about words that tell us to use an equal sign, is was one of the most common ones used. Is helps differentiate these from operations, because phrases like less than and more than could tell you to subtract or add, but when you have the word is in front of it, it turns it into an inequality symbol. So please make sure you keep these in mind and use this paper to help you when we do the examples below and any homework you're working on. So scrolling down to the examples at the bottom, we've got a couple different kinds. We've got kinds where we are given a sentence and have to turn it into an algebraic inequality, and the other way around. I'm giving you the inequality and we have to turn it into a sentence. I want to go down the left side first with 1, 3, and 5. So it says the difference between x and 2 is greater than negative 10. there's a couple things that you want to be looking out for. Number one, you want to be looking out for the word or phrase that tell us to use an inequality symbol. And you also want to look for any word or phrases that tell us what operations we're using. So the words that stand out to me are the word difference, which tells me to subtract, and is greater than, which tells me the inequality symbol I'm using. Difference tells me I'm subtracting, and I'm finding the difference between x and 2, which means I'm subtracting x and 2. Is greater than tells me to use the greater than symbol, so that's exactly what I'll write. And everything is greater than -10. So that will be on the other side of my inequality symbol. Moving down to number 3, twice a number plus 5 is not fewer than 22. I've got a couple words in here that are important. Twice tells me I'm multiplying by 2 specifically. Plus tells me I'm doing addition. And is not fewer than tells me I am using a greater than or equal to sign here. If you didn't know that in your head, there are a couple different ways we can figure this out, and I'll go through that after I write the beginning of this inequality. So twice a number means 2 times a number. Since they didn't tell me what it is, I use a variable. I'm just going to use x. You can use any one that you want. Then plus 5 tells me I'm literally going to write plus 5. And the is not fewer than, like I said, it does tell us greater than or equal to, but if that's not something you remembered, another way to figure it out is just to ask yourself some simple questions. If it's not fewer than 22, that does mean that it could equal 22, so then there would be that line at the bottom. And if it cannot be fewer than that, it could be larger or greater than that. So my inequality is 2x plus 5 is greater than or equal to 22. Number 5, again, working down the page, 12.5 is fewer than the quotient of m and -2. Is fewer than tells me an inequality. Quotient tells me division. So I'm going to start with 12.5. And this is fewer than is the same as, or is a synonym of, is less than. So that's going to be the inequality I write. Quotient tells me I'm dividing, and I am dividing m and -2. That's it. That's all there is with that one. I'm going to skip number 7 for right now. We'll come back at the very end. Let's work on number 2, 4, and 6 next. So we are actually turning these into sentences. There's going to be a lot of different options here. I'm just going to be writing one of them, but I'll talk you through a couple different ways we could write them. So for number 2, reading it out loud usually does give you a hint as what you could write. This one I would read as -5 plus y is greater than or equal to 11. And I could write down exactly what I just said out loud. I could literally write down -5 plus y. I could say -5 raised by a number, -5 increased by y, the sum of -5 and y, any version of those, and a couple others you could write. I'm going to choose to write -5 increased by y. And then I've got my inequality symbol. It's a greater than or equal to symbol. So I could simply say is greater than or equal to, or I could use any of those phrases that are in the columns above. I could say is at least, is at minimum, is no less than, is not fewer than. I'm going to go ahead and choose is at least. And it is at least 11. There's my sentence. Number 4, it starts with 1/2 is greater than 5w plus 6. Again, a lot of what I read out loud could be a hint for what you could write. I am going to start with the number 1/2. And for my inequality, is greater than, I could literally just say is greater than. I could say is more than, is larger than, is above, is over. All of those options on the top column there. I'm going to go ahead and just say is over. 5w. I need to add a word in there that tells me what I'm doing with those numbers. And when a number and a letter are next to each other, that shows multiplication. So I could say 5 times a number, the product of 5 and w. There are a lot of different options. I'm going to go ahead and say 5 times a number. And for plus 6, I could write plus 6, increased by 6, raised by 6, any of those. I'm going to go ahead and just write plus 6, and that one will be done. And number 6, I have x over 4 minus 3 is less than or equal to -25. X over 4, that's a fraction, and fractions are always represented by division. So I need some words to tell me I'm dividing x and 4. I could say x divided by 4. I could say the quotient of x and 4. Okay, there are a lot of different ways. I'm going to go ahead and say the quotient of x and 4. And the quotient of x and 4, I could say subtracted by 3, minus 3, decreased by 3, lowered by 3. There are, again, a lot of options here. I'm going to go ahead and just say minus 3. For my inequality symbol, I could say is less than or equal to. I could say is at most, is at maximum, is no more than, does not exceed. Any of those are fine. I'm going to use is at most. Negative 25. And that one's done. And we have one final question to go through. This is a word problem. It says Sharon needs to take a taxi to the airport. The taxi charges a flat fee of $5 to pick someone up and an additional $1.25 every mile. Sharon has no more than $20 to spend on the taxi. Write an inequality to represent this situation. So reading through, there is something that I don't know, and what I don't know is the amount of miles they're going to be traveling. So that's going to be my variable. I'm just going to use M. You could use any variable you want, and that's going to represent the miles. The other thing I know is I have this ultimate or ending value, and specifically that would be that she has no more than $20 to spend. So that $20 is going to be all by itself on one side of the inequality. Just like in an equation, we try and find what that ultimate or ending value is, but instead of putting an equal sign in front of that 20, I'm going to use this phrase no more than to help me figure out the inequality I use. If you look back at those phrases towards the top of the paper, we have is no more than under the less than or equal to symbol. Another way you could figure that out is by saying if it's no more than $20, that means she could spend $20, or it could equal $20, or she could spend less than that, which is why we're using the inequality less than or equal to. Now, to get to that $20, they did have to pay this $5 pickup fee. It's a one-time fee, and an additional, which means plus, $1.25 every single mile, but I don't know how many miles I'm traveling, and that's where my variable comes in. And since that $1.25 is going to be increasing every single mile they drive, I would be multiplying the number of miles. And this is my inequality for this situation. If you have any questions about writing inequalities, please check in with your teacher and ask.